Hello everyone, I am Rahul Kumar, final year civil engineering student, Faculty of Engineering and Technology, University of Lucknow. I am going to give a seminar presentation on the topic application of particle image velocimetry to investigate pile-soil interaction behavior under the guidance of Jitendra Pratap Singh sir. Let's get started. Here I have mentioned a table of content, that's introduction, why to use imaging, historical development of PIB, basic principle of PIB, component, experiment and result, application, 3D PIB technique, limitation, case study, conclusions and references. First one is introduction. First, we have to study what is the flow measurement technique. There are two techniques for flow measurement. First one is intrusive method, second one is non-intrusive method. In intrusive method, we use orifice meter. In orifice meter needs to interact directly with the fluid. Here the picture of the orifice meter. And second one is non-intrusive method. It uses particle image velocimeter without interfering with the fluid. Here the picture of particle image velocimeter. Next one is how to use imaging. There are two types of method for measuring. First one is conventional method, that is also known as SWM LDV. Second one is particle image velocimetry. In conventional method, we adopt single point measurement, traversing of flow domain, time consuming, only turbulence statics. In particle image velocimetry, we studied whole field method, non-intrusive method, instantaneous flow field. Move to next slide, that is historical development of PIB. Quantitative velocity data from particle streak photograph in 1930. PIB was born as laser speckle velocimetry. The specific characteristics scattered laser light that caused the phenomenon called speckle was used to allow the measurement of the displacement of the surface of sample subject to strain. Next one is basic principle of PIB. It is based upon the measurement of the velocity of tracer particle in the fluid. A plane of the flow under investigation is illuminated using a laser. Tracer particles are therefore made visible and image of the illuminated particle will be recorded. The instantaneous velocity of a fluid is measured through the determination of the displacement of the tracer particle illuminated by a sheet of light. The actual measurement is consequently performed in two successive steps. First one is recording of image, second one is processing of the image to determine the tracer development. Here is the picture of schematic diagram of principle behind PIB. That it is shown here the double pulse letter, here the measurement volume, light sheet, target area, imaging optics, CCD, correlation, data analysis and data. The next slide, that is components. The component, that is high speed camera, a high power multipulse laser, an optical arrangement to convert laser output light to a light sheet, a synchronizer. Next one is experimental setup. Density of fluid in a water tank set using a hydrometer. Add seeding particle at constant head. Turn on laser and synchronizer. Capture image using CCD and analysis data. Next one is results. Two consecutive frames arrows from processing image. Two vertices spotted. Here is the picture of head of displacement arrow at final position and tail of arrow at initial position of the speed. That was conducted by MATLAB technique. Application. First one is prosthetic heart valve, as the picture here shows. Motion of the fishes in the water. and aerodynamics analysis of the helicopter. Here is the picture of application of EIB that I have mentioned earlier. Next one is 3D PIB techniques. In general, velocity component towards or away from the camera are not calculated. Absence of z component of velocity may also lead to an error in xy component due to parallax. Other EIB techniques used for obtaining the third component of velocity field, such as scanning PIB, defocusing PIB, holographic PIB, 3D PIB. Here the in the next slide, picture of scanning PIB and defocusing PIB. In scanning PIB, we see that here is the laser and scanning optics. Here mentioned flow, measurement volume, scanning insert seat, synchronization device. Coming to next slide, that is 3D PIB technique. Scanning PIB. One or more cameras observe the measurement volume as a laser seed is scanned across it. Next one is defocusing PIB. A point in the space of axis from an aperture will have an image that experiences a lateral offset as the point moves along the axis of the optical system. Third one is holographic PIB. Hologram is recorded by superimposing the scattered particle light, the object wave with a reference over on a photographic plate. The developed photo, the hologram, is illuminated with the reference wave and diffraction from the pattern produces a wave that seems to originate from a particle field, the virtual image. By reversing the direction of the reconstructing wave, a real image of the particle field can be produced in a space. Next one is 3D PIB. The particles located in a speed seeded volume are imaged by 3 or 4 synchronized CCD cameras arranged convergently. The camera or the illuminated must be mounted on a platform moving approximately with the mean velocity of the flow. Here, in the next slide, I mentioned the limitations. Scanning PIB, not suitable for thin, few hundred micrometer, near wall region as the characteristic time scale of the flow is small compared to scanning time. Holographic PIB, it is complicated and require high resolution CCD cameras. Next one is 3D PIB and DD PIB. Ambiguities in the particle's position resulting from reconstruction approach. Move to next slide. Here the case study of the particle image velocimetry. The location of the project was Department of Civil Engineering, CMR Institute of Technology, Bangalore in India. The experimental studies are carried out in a steel tank of dimension 450 mm into 200 mm in plan and 450 mm deep. The front side of the steel tank is made of perspex to facilitate image capture. Two half section aluminum piles of hollow and solid section with same flexural rigidity are used in experiments. Wood's scaling law is employed to model pile dimensions. The infill material has an average size of 3.8 mm and experimental studies are carried out at a uniform density. Under axisymmetric conditions, the piles are driven at a uniform rate and the deformation of the infill surrounding the pile are seized using a high-resolution digital camera. The images are used as input in GeoPIB software and analyzing is performed using MATLAB code to capture soil-pile interaction. From the analysis of experimental results, it is observed that zone of interference of hollow pile is more than solid pile. Move to next slide. From the present experimental study, the following conclusion can be made. PIB technique is successful in capturing soil-coil interaction. Though the flexural rigidity is same, zone of influence is more for hollow pile rather than solid pile, which could be due to lesser mass density of hollow piles. Move to next slide. Scope for future work. This paper presents a pilot study carried out to demonstrate the effectiveness of GeoPIP as a tool to study pile-soil interaction. Even the size of infill material used for the experimental study is slightly large, hence detailed experimental studies are carried out to understand soil-soil interaction for different in situ soil conditions. High-resolution images facilitate use of control point analysis in GeoPIB, which will help us in correctly estimating the zone of soil-soil interaction with respect to diameter. Come to next slide. Here is the conclusions. It is capable of measurement of flow fields near vaulted and deformable wall. Aero as low as 2.29% of particle diameter 1.76 micrometer. In the distance of particle from wall, accuracy of the horizontal movement was comparable with that of PIB and PIB measurement techniques, which is 0.0255 pixels. However, achieved accuracy in vertical movement was 5 times lower. Relative measurement uncertainty in the range 2% to 10% in the dependence of the distance between particles and walls. Here is the references of particle image velocimetry that I have studied. Thank you.